B, in practical 2.1, do the following analysis by writing a Python script in Jupyter Notebook and utilizing the PCA method. We have three classes, three types of iris flower, and we're going to actually do this analysis. First, illustrate the first and 5 samples of this data set. What is the minimum and maximum values of this data set? Illustrate the histogram plot of the feature. This includes sepal length, sepal width, petal length, petal width. Okay. So, and then applying PCA method on this and identify the most significant principal component. How many components are representing the most variances of our data in this case? 3, we're going to illustrate the plot of cumulative explained variances versus the number of components. And 4, illustrate a 2D PCA visualization of samples according to the target labels obtained from dataset 2. What can you infer from this plot? And the plot would be similar like this. And 5, by applying a feature scaling technique, transform the original data set value range into the range of 0 to 1 and repeat the above analysis. We're going to do feature scaling at the end of this analysis. Okay. Let's start the analysis. So we're going to do a sklearn dot. I'm pressing tab, decomposition. And then import, we said PCA class. Okay, so this is 4 libraries we need for this analysis. And we add libraries if we want to have a 3D PCA analysis as well. Okay, so this is for loading libraries. The second one, the next one is going to be, we're going to do pre-processing on pre-processing stage, including reading data set as well as examining the data set. Okay, so I'm going to do this markdown. So, okay, the data set that I have is PD dot, sorry, it's an iris data set and my folder. So PD dot read CSV, and then let me show you the data set that I have here is this one. Okay, as you downloaded your computer as well. So it's iris data set, no columns. So it's iris data set underline no columns .csv. Okay, so I'm gonna read this and put it in data frame columns. So I read this data set. It looks there's no problem with this. Now I'm gonna actually see what I have read in this part. So the data set which I have read here is this one. 0 to 148, which is 149, and I have 5 columns. Okay, what is the problem with this data set? Can anyone tell me what is the problem of this data set? Anyone? Exactly. The first row is the column actually includes the first row of our data. So the data is here, which is the column name, and we don't want to do this. So remove this problem. Okay, so what I'm going to do is adding a columns. Okay, so I'm going to add columns, column names equal, let's say, SL, abbreviated way, SW width, W, and then two other one was PL, petal length, and also sepal petal width, sorry. Yeah. Also, I had a target, or let's say a class label. So now I can say df underscore CLM PD, sorry, read CSV, and the data set, which is exactly the same name here. Yeah. And I'm gonna actually use names, name, and press tab, and then giving this column names that I defined here. Column names equal column names. Sorry, column names. Okay. Okay, so if you run this line, and now viewing the data set, we will have a proper data set, including numeric values for these four features and class label of samples. Columns are features, including the target or class label, and rows dedicated for samples. Okay. Another thing that I can do is give name to the sample rows. Okay, so I'm going to give some name to sample rows because it's starting from 0 to 1 to 149. So I'm going to give them name. So, and 149 is the index of the last sample. Yes. So I'm going to use this variable prefix, which I'm defining for, let's say, a sample. Okay, because I want to have row names starting with samples, and then say sample underline names, which is a list, would be with this format, F, and then prefix defined, then underline, and then I plus 1 for I in range of n plus 1. So This is a for loop that I'm going to use here. I is changing from the initial one, which is 0, and then till n plus 1, which is 150. So if I print these sample names, you can see I created a list of characters, or let's say a string, sample underline 1, 2, 3 till sample 150. Yes. So now I can give this name to the row names of this data set. So the data set is df underline CLM. So to access to the row names of this data set, I'm using index. If you press tab, so you will get this, and then sample names. So if you run this line and then add df, and you can see now we have a data set, proper names, proper column names, including our data, numeric data, as well as the class label of each sample. Yes. Okay. Any question till here? Okay. So now we're going to actually look at the illustrate the first and last 5 samples of this data set. So we have now data set. Let me say we have now data set ready for our analysis. Yes. So what we're going to do, seeing the first and last 5 samples of this data set. So the data set df underline dot head. By head, we can, by this, we can actually get the 5 first, and df dot tail, we can get the last 5 samples of this data set. Yes. Okay, this is the first. So what is the minimum and maximum values of data set? Okay, so before doing this, I'm gonna actually separate the numeric values from the categorical values that we have here. So the last feature, class labels, is a categorical type. So I'm going to separate this. So separating out the features. X, let's say X equal df so let me see. Yeah, okay, let me see. Let me do it this for the sake of shortness of the. I'm gonna actually change this to df. This one would be easier to follow. This one df, and then this one is tail. I'm gonna just use the data for easier. Okay, is the question from Jack? Is the head and tail always 5 rows, or is different for different? No, it's always 5. Yes. is always 5. You always actually seeing the top and the bottom of the data set. OK. So what I'm going to do is first, let's say features. I'm going to define these features. Features equal data frame dot columns. OK. So I'm going to just choose from 0 index, 0 columns, to 4, excluding the 4 one. So inclusive 0 and excluding 4 columns. OK, so and if you look at the features here by running this, we can see that we have access to the column names. OK, so now I'm going to actually separating this. Here we select a subset of columns from the DF data frame. OK, and we actually save into a features variable. OK, so now we're going to actually use X variable data frame dot location. If you press tab after dot, you can find this. After L, you can find this LOC. And then I'm going to use all the rows by column, comma, and features. Excuse me. So I'm going to just use 4 features, SL, SW, PL, and PW here. So all rows, 150 rows, identified by column, and the features, the columns which identified by features, which is just 4 features, and the values. If you just press the values, called the values, so you can extract subsets of data from DF. OK, so and with Y we can variable DF dot location, again similarly location, all rows, comma, and class label. This must be in bracket, square bracket. Dot values. OK, now I can see the X, which is a list and an array of all the values related to these features, starting from 5.1, and also I can get Y variable, including all the class labels of the data sets. OK, so mean and max values was we say max X. Now we can apply finding mean and max by this NP numpy and then a max and X. So we're going to find the maximum value of X dataset, which is an array, and max X. If we run this 7.9, and likewise for mean values, mean X equals numpy dot a min X. So if you run this, the minimum value would be 0.1. Okay. This is maximum. This is maximum. This is the minimum. You can use only np dot max as well, but a max is more efficient, and for large arrays, it's working better than only using max. So you can use np dot max or np dot min, but using this function actually help for large arrays. Okay. Okay, you can for instance, display X only 4 columns from 0, 1, 2, 3, 4 isn't excluded 5. Now, if you want to illustrate a histogram, you can go with a data frame and tap histogram, and then columns equal the column is first one is sepal length, and we can use the number of bins or interval equal, let's say 10 intervals. So this is the histogram of the first column of data set. So 5.1, 4.9. This is the histogram, and you can change the intervals in this histogram, something like this. Okay.